Hello and welcome to my presentation for Assignment 3. When designing the GUI application, it made the most sense for me to split the GUI design into 5 separate sections. So the first component is a simple 10 tracker display panel, which displays new events as they are received. The second component is the latest event display field. This displays the most recent GPS event at the time it occurs, and it can be from either one of the 10 tracker streams. The third component is the control panel, which allows users to filter GPS events based on the specific latitude and longitude boundaries that they can enter into the provided text fields. The fourth component is the most recent filtered event display field, which displays the filtered events that fall within the set boundary. The fifth and final component is the distance field in the simple tracker display field, which outputs the distance traveled for each tracker over the last 5-minute interval. Now if we look into the code here, I've written everything in the GPS GUI.java file. I've structured this file so that there are 5 main functions for each component I mentioned before, which all come together in the main function which sets up the GUI application. Separating this functionality into separate functions made it more modular and ensured that the code was easier to test and debug. The Create Tracker Display panel function sets up a real-time GPS tracker display using the JPanel with a grid bag layout to format a table with columns for tracker, latitude, longitude, and distance. It processes GPS events by creating GPS event cell objects that hold the latest event data from each GPS event stream in an array. The function then maps each event into specific data points using dynamic S labels to display this information, updating automatically as new GPS events arrive. The stream and cell objects handle real-time updates, ensuring that the tracker data refreshes continuously. Next, the Create All Events panel function combines these streams into a single event stream, displaying each new event as a comma-separated string on an S label. The panel clears automatically after 3 seconds if no new event arrives, with a timer that resets the label to no valid events. Each new event restarts the timer, ensuring the display always only shows the latest GPS data. Test Create Control Panel first checks that the method returns a valid JPanel. It then verifies that the panel contains at least one component and looks for the minimum and maximum latitude text fields, as well as an apply button. The test assigns the first 2 text fields for the latitude inputs and the button for applying these changes. Finally, it confirms that these components are present, both text fields are empty, and the apply button is labeled apply. The setup distance calculation methods listens for incoming GPS data and uses the snapshot primitive to capture consecutive GPS events, allowing it to calculate the distance between them with the calculate distance function. This distance is then accumulated to keep a running total of the distance traveled, updating every 5 minutes. The GUI is refreshed accordingly to display this total, ensuring that each tracker's distance remain current. The method is called within Create Tracker Display Panel to ensure real-time, up-to-date distance information for each tracker. We also have some helper functions. Is valid latitude and is valid longitude? Just check that the input values entered by the user are within the acceptable boundaries. Next, since the altitude is originally in feet, convert altitude converts this value from feet to meters by multiplying it by 0.3048. Finally, calculate distance takes 2 GPS events as parameters and then computes the distance formula on them to calculate the distance in meters. Here we have the testing suite for the GPS GUI file. Test Create Tracker Display Panel checks if all necessary fields are correctly added to the simplified Tracker Display GUI. It first confirms that the panel is created and not null, then it checks that it contains the 16 expected components. Finally, it verifies that the header labels tracker, latitude, longitude, and distance are displayed correctly. Test Create All Events panel starts by calling the method GPS event streams to create a new JPanel and ensures that the panel is not null, indicating successful creation. Next, it verifies that the panel contains at least one component, confirming that the most recent event has been added. Finally, it checks the presence of an S label in the panel, which is essential for displaying the latest GPS event. Test Create Control Panel first ensures that the method returns a non-null JPanel, confirming that the control panel is created. Then it verifies that the panel has at least one component and looks for specific components, the minimum and maximum latitude text fields, and an apply button. The test assigns the first two text fields to hold the latitude inputs and the button to apply changes. Finally, it checks that these components are present and confirms that both text fields are empty and the apply button is labeled apply at the start. Test valid latitude and longitude checks if the isValid latitude and isValid longitude methods correctly determine the validity of latitude and longitude values entered by the user. It verifies that valid values return true and invalid values return false. Test apply button functionality starts by creating the control panel and locating the minimum and maximum latitude input fields and the apply button. After identifying these components, it sets valid values 10 for minimum latitude and 20 for maximum latitude. The test then adds a listener to the apply button to ensure that the current latitude labels update correctly when the button is clicked. Test convert altitude checks if the function accurately converts 1,000 feet to meters. Additionally, it tests how the function handles a negative altitude of a negative 100 feet, ensuring it returns -1 to indicate an invalid input. Test calculate distance then checks the accuracy of the distance calculation between two GPS events from the same tracker. It creates two sample GPS event objects representing locations on a Cartesian plane and confirms that the calculated distance matches an expected value. Now I will run through a demonstration which will showcase my manual testing. On launch, we can see that everything is being displayed the way it should be. The simple 10 tracker display panel has been added and is frequently being updated with new data in real time. The latest event panel down here is also displayed and is frequently being updated with the latest tracker event as it receives it. When it receives a new event, it also updates it to the 10 tracker display panel, which is a good sign. As you can see, tracker 5 is the same value. Now, after 3 seconds, we can also see that no new events are being received, so it will update the label to say no valid events while it waits for a new one to come along. After 30 seconds passes, we can also see that the distance values update for each tracker, showing that it is calculating and displaying the distance traveled by each tracker within the set time interval. After another 30 seconds passes, we can also see that these values update again and are different to what they were previously, indicating that the sliding window feature is also working as expected. You can also see that the filtered events panel is also being displayed down here. Currently, as we've not set any boundaries yet in the control panel, it has no events to display, which is a good sign. Now we can set some boundaries using the control panel down here. To begin, we can test by inputting some invalid values that fall outside the latitude and longitude boundaries. So we can enter some invalid boundary values like this, keeping in mind that it has to be between -90 and 90 for latitude and -180 and 180 for the longitude. So if we click apply now, we can get this pop-up message telling us the boundary values we need to set them between. We can also do this if there's words in here, so these should only be numeric values. So if we click apply now with a value that says hello, it'll tell us that we need to enter valid numeric values. Now let's say we input some acceptable values. When we press apply, the request will be accepted and the current latitude and longitude values will be updated with the values we inputted down here. Now we can wait for a new event to pop up in the latest filtered event panel. Now here we go. As you can see, the latitude and longitude values of this event fall within our set boundary. And if we wait 30 seconds, we should see that the distance values update based on our filtered events, which is a good sign, as you can see here. We can tell this worked because only one tracker's distance value was recorded over this 30-second interval. And after we wait another 30 seconds, we should see this value update again thanks to our sliding window implementation.